an order and will pick up your store. Those are the perfect time to start such monitoring process. You don't want to do it too early. You don't want to do it blindly at every startup and have that arrow show up unnecessarily. So now your customer finally comes to your location. At the entrance, iOS detects that the user crossed the boundary of this region. So this location manager did enter region callback will be invoked. Before I expand this method, let's take a minute to think what we're trying to do here. So the ultimate decision we want to make is whether it's appropriate to post a welcome notification to the user. If the user's order is not ready, it's not the time for their dinner, there's probably no point to show anything to them. However, in most of the systems, this decision can only be made on the server side because the user's order status, their reservation information, their guided tour schedule, those are all stored on the server database. Your app doesn't have that information right away. That does mean your app will need to make a server call potentially in background because this will wake up your app in background when your app is not running. That will involve another technology called background execution. It's part of iOS multitasking, and there are lots of documentation and sessions about that. So I won't get into the details. I'll just show you how we use it in our particular example. Now let's expand the code. The first line is just a sanity check to make sure my geofence manager is the right object to respond to this event. Because the region events are delivered to all of the core location delegates of your app, not only the one that registers for this region. So you need to keep that in mind. The second line is just my way of telling you, hey, I'm only demonstrating the background case. Once you understand this, you can easily figure out the foreground case on your own. It's even simpler. The next one is the safety check I'm talking about. So imagine your location is in the middle, middle of a busy area. Your restaurant is in the middle of a mall. It's totally possible for the user to cross the region multiple times in a short period. If you blindly start your app and do all these resource-intensive things like making server calls, every single time the user crosses the region, for sure the user will notice that their battery drains faster than usual. You don't want that to happen. You want to prevent that. So what you can do is to use information such as the timestamp of the past location events to see if enough time has elapsed since the last time they crossed the region. If that's not the case, you should tell your app to just go back to sleep without consuming any more resource. That's key to saving battery. Now we finally enter the real business. First thing you need to do is call UI application begin background task API to request additional background time because you are going to do a server call and it might take a few seconds. So there's a lot of documentation for that. There's only one thing I want to call out is that be a good citizen when your app is in the background. Implement a meaningful expiration handler block so that iOS can invoke to do the cleanup work in case your task runs for too long. If you don't do that, iOS will eventually terminate your app. Now you requested the additional background time. You can actually start the server call. This would be exactly the same if you want to do it in the foreground. Here I'm using my service manager object to take care of all the URL connection, HTTP details for me. So what I'm doing here is providing a completion block that will be invoked by my service manager when the server data has been received by the app. So let's take a look at what we do. Rule number one, for any client-server app, check against error. Never ignore an error. Okay. And if you get no error and you actually get meaningful information from the server, such as the user's order is ready for pickup or the table is ready for their dinner, you create a UI local notification object. You fill in the details using the information you received from your server. And it's very easy. You just call this present method on UI application object to present that. Also, you can optionally put a private user info to your local notification. So later, when user opens it, you know what notification it is and how your app should react. We're pretty much done. There's one last thing you need to do. Remember, you begin a background task earlier. You need to end it. If you don't do this, your app will be terminated by iOS eventually. So that's all the code you need to add in order to make this work. Now let me show you how this actually works on the real device. So I'm the visitor. I have a guided tour booked at the Louvre Museum for today. As I approach, my phone is still in my pocket. It's still in the locked mode. And I'm expecting a welcome message to tell me where I should meet my tour guide. So in order to do this demo, because I cannot move around with this cable attached, so I'm going to get help from our engineer, Matthew. Matthew's holding an iPhone that is programmed to be a beacon transmitter. He's got this little app where he can turn on and off different beacon signals. So when he turns on the region beacon, it will be exactly the same effect as if user crossed the boundary of the region. So let's see how it works. Matthew, can you turn on the region for me? As you can see, as soon as Matthew turns it on, the notification is posted on the user's welcome screen. It says, thank you. It gives you some meaningful information. If as a user I swipe and open, your app is launched in foreground and you have the freedom to do whatever you want. So again, this is at the entrance of your location. Okay, so compared to the regular geofence where you have today, it probably notifies the user at the parking lot. Now with this, you can notify them at the entrance. So that's my first demo. Only 2 methods. It really couldn't be any simpler. Let's move on to the next demo. The next demo is about a ranging use case. So imagine you are the owner of a large museum. You have hundreds or thousands of artwork pods in your exhibition area. What you can do is to attach a beacon to each of the artwork such that when user is in your museum and they're running your museum app, they can get additional information about the artwork they are closest to. So let me show you how to do it in code. Again, 2 methods. First method is to start the ranging process. This tells iOS, I'm ready to receive signals. Please monitor beacon signals around me and report them back to me. So 3 lines of code. First thing first, you create a UUID. You need to use the same UUID between your app and all of the artwork beacons in your museum. Maybe you have 500 of them. It doesn't matter. You use all the UUID. You use the same UUID on all of them. So there's really no practical limit for you. And then you create a CO beacon region object. It's very similar with the previous demo. And last, is this time we're calling the start ranging API instead of a start monitoring API because we want to do active scanning. So that is it. From now on, iOS will start monitoring the signals around you and report them back to you. I would call this method whenever my app goes to the foreground and the user is confirmed to be within the range of my exhibition area. So let's take a look at the core location delegate callback. Location manager did range beacons in region. This is where iOS tells you I found 1 or more beacons around you. Notice that the beacons parameter is an array because at any time you could see multiple beacons around you. They are sorted by the perceived distance. So the one that's believed to be the closest is at the top of the array. So let's expand the method and see what we do here. First line, I'm just trying to use a utility method to inspect if the closest beacon is within a desired threshold. Here I'm using CL proximity near as my threshold, which represents a distance of roughly 3 meters. So this entire line basically means try to find the closest beacon that is within 3 meters. If the reason I make it into a utility method is because I might want to use it somewhere else in my app, and it makes unit test easier. But inside it is really just an object at index 0, cast it back to the region, and check the proximity property. And if 1 is found, I can inspect the major value property on the beacon to tell whether it's the painting or it's a sculpture. So we programmed all the artwork beacons using the same UUID. So you might ask, how do I tell whether it's a painting or a sculpture? There are other customizable values on the beacon. They are called major and minor properties. Each of them is a 16-bit integer, so you can define the value of them. So in my case, I specify 1 to be the Mona Lisa painting, and I use 2 for the Wind Victory statue. So by reading the major value, I can give a hint to my UI code. OK, this is Mona Lisa. That is the Wind Victory. So you can show different pages. And if, of course, if user has walked away from